How channel operating margin helps Gigabit Ethernet printed circuit board analysis. Gigabit Ethernet is a revolutionary technology that has revolutionized the way we transfer and receive data. However, to ensure the proper performance and functioning of a Gigabit Ethernet printed circuit board, it is important to consider the channel operating margin, COM, of the design. We want you to understand the importance of COM in Gigabit Ethernet printed circuit board analysis, including the factors that influence it, its impact on the system, and how engineers can use it to improve the performance of their designs. Gigabit Ethernet printed circuit board analysis can be challenging and time-consuming, but understanding the concept of channel operating margin, COM, can make it easier. COM is an important factor in any high-speed data transfer, and having its understanding can make it easier to design a Gigabit Ethernet printed circuit board that can handle the data throughput you require. What is channel operating margin? Channel operating margin is a measurement of the amount of noise that affects the electrical signal sent and received between 2 points on a PCB. Engineers use it to assess a PCB design in terms of functioning over a given channel or interconnect between components. You can do COM analysis in both the time and frequency domains. It helps to determine if the specific design meets its performance requirements. Defining the main parameters of COM when evaluating a design, it is important to consider COM as it can affect the quality of the signal and the reliability of the circuit. The main parameters of COM are insertion loss, return loss and crosstalk. Insertion loss, it measures the energy loss of an electrical signal as it travels from one point to another within a PCB. Return loss, the return loss measures the energy reflected from a transmission line. Crosstalk, it occurs when an electrical signal from one line couples into another line on the same board, creating interference and degrading signal integrity. The goal of COM analysis is to maximize the margin between these noise levels and the target signal strength, while still meeting the performance requirements of the board. This margin is often referred to as headroom, as it provides additional protection against unexpected noise which could otherwise cause system errors or failure. By properly assessing COM through analysis and simulation, engineers can ensure that their design meets its intended performance requirements. Tips to improve channel operating margin. As we discussed that improving the channel operating margin for Gigabit Ethernet PC board analysis is essential to ensure reliable data transmission. The basic purpose is to reduce crosstalk and other types of interference that can impair the performance of the system. Here are some tips to help you improve your channel operating margin. Adjust trace length. By adjusting the length of traces between the transmitter and receiver, it is possible to reduce the crosstalk between channels. Control board stack-up. When creating a board stack-up, you must consider the spacing and routing between the components and layers. This will help to prevent interference between signals and reduce crosstalk. Minimize power forward/ground noise. To minimize noise on the power or ground planes, you must use adequate shielding and decoupling capacitors. This will ensure that the signal quality is maintained. Select high-quality materials. You should use materials with good electrical characteristics to maximize the channel operating margin. Using lower quality materials can lead to higher losses, which will reduce the overall performance of the system. Optimize trace width. By optimizing the trace width, it is possible to minimize signal losses while maintaining signal integrity. By following these tips, you can improve the channel operating margin and ensure reliable data transmission for your Gigabit Ethernet PCB analysis. With careful attention to detail, you can ensure that your system meets the highest standards of performance and reliability. How to use channel operating margin to improve your Gigabit Ethernet PCB analysis results. Channel operating margin is a metric that measures the performance of your transmission channels, giving you a better understanding of the performance levels of your systems. It helps in evaluating whether a system has adequate signal margins, which helps ensure that errors won't occur. To use COM for your Gigabit Ethernet PCB analysis, you should first calculate the available operating margin for each transmission channel. You can do this by using a combination of tools, such as eye diagram measurements, eye mask measurements, and reflection measurements. After calculating the available operating margin, you can then determine how much noise or crosstalk is present on the channel. The more noise or crosstalk present, the lower the available operating margin and the lower the performance of the system. After evaluating the available operating margin and determining the amount of noise or crosstalk present on the channel, you can then adjust the design of your PCB to reduce these issues and improve performance. You may need to increase trace widths or change materials used to reduce crosstalk or dampen noise. By making these adjustments, you can improve performance and increase the available operating margin. What are the benefits of using channel operating margin for Gigabit Ethernet PCB analysis? There are many benefits of using COM for analyzing the Gigabit Ethernet PCBs as described below. Channel operating margin is also an effective way to troubleshoot potential design issues. This helps ensure that a PCB is properly designed and optimized for its intended purpose. COM provides several benefits when it comes to Gigabit Ethernet PCB analysis. Such as, COM can provide an overall snapshot of the board's performance. It helps you to identify the areas of weakness or failure which may be hard to detect with traditional testing methods. Channel operating margin can also help you pinpoint the problem areas, such as noise levels, signal integrity, power consumption, and crosstalk that could be causing your Gigabit Ethernet PCB to underperform. COM helps you to test different board configurations and make changes before committing to a final design. This can save you time and money down the line. Channel operating margin is an invaluable tool for optimizing Gigabit Ethernet PCB designs. Its comprehensive analysis capabilities allow you to fine-tune your board for maximum performance and reliability. By utilizing channel operating margin in your analysis process, you can ensure that your Gigabit Ethernet PCBs are up to snuff and ready for production. COM and high-speed PCB analysis. COM also helps analyze high-speed PCB having high-power data channels that go from IC to connector lying on the PCB edge. Many things influence the strength of the signals that pass along with high-power data channels or lines, such as track dimensions, track type and length, data patterns, temperature dependency of signals, PCB materials, dielectric properties, vias, physical alignment along the channel, disconnection between the component pads, and track. Manufacturers use algorithm-oriented techniques like COM to ensure compliance with high-speed design. This is especially true when the speed goes more than 25-bit/sec. The compliance becomes even harder when the data goes up to 3-bit/sec or more. Engineers use eye diagrams and equalization techniques along with COM for high-speed data. These techniques help analyze the channel, transmitter, as well as receiver. Frequently asked questions: what is channel operating margin in PCB? COM is the difference between the PCB's actual data transmission rate and its maximum achievable data rate. Why is COM important? COM is an important factor to consider when designing and analyzing printed circuit boards for Gigabit Ethernet applications. What are the main parameters of COM? The main parameters of COM are insertion loss, return loss and crosstalk. What is the benefit of COM? Channel operating margin, COM, is a powerful tool for analyzing Gigabit Ethernet PCBs. You can use it to evaluate the performance of a circuit board and determine how robust it is. Why should you use COM for analyzing Gigabit Ethernet PCBs? Using channel operating margin for your Gigabit Ethernet PCB analysis is a great way to ensure that your systems are performing at their highest potential. By calculating the available operating margin and adjusting the design of your PCB accordingly, you can improve performance and increase reliability. Final thoughts: the performance of a Gigabit Ethernet printed circuit board, PCB, gets influenced by its channel operating margin. COM is the difference between the PCB's actual data transmission rate and its maximum achievable data rate. You must understand the impact of channel operating margin on Gigabit Ethernet PCBs to ensure the performance and reliability of the device. Gigabit Ethernet PCB analysis requires an understanding of the importance of channel operating margin. COM is an important factor to consider when designing and analyzing printed circuit boards for Gigabit Ethernet applications. COM is a measure of the electrical performance of a PCB, specifically its signal integrity, and can have a major impact on the performance of a system. Engineers have worked a lot to find the importance of COM in Gigabit Ethernet PCB analysis, including how it affects the electrical performance of a PCB and the various factors that influence it. Would like to know more about the channel operating margin or prototype PCB manufacturer? Email us at sales@nconline.com. That's sales@nconline.com. That's